Vectors really are quite simple, but many people seem to think they're a little bit more difficult, but not really. Let's have a go. Right, when we write a vector, we think of something moving from one point to another. And let's label these points A and B. And so I'm travelling from A to B. And so I would write that as going from A to B. And we put a little arrow over it. Similarly, I could in fact go the opposite direction. I could go that way. And that would be the vector of B to A. And we'd write it like that. So basically all vectors have a distance here that they're travelling, an amount, and we'll call that their magnitude. And they have a direction in which they're travelling. And so there is our basic idea of a vector. If I say that two vectors equal one another, so let's say that vector AB equals vector CD, then it's most likely here that these two are in fact parallel lines. There's my vector AB and my vector CD going in the same direction. They are parallel to one another. If we want to, then we can talk about a vector going in the other direction. So let's have two other vectors. And I've got this one AB here going this way. This is the vector BA going that way, and we can say simply here that vector AB here equals the negative vector here of B to A. Now we can also play around with adding vectors together. So let's take a simple triangle. I'm going to have some vectors. This is A and B, this is B and C. So I've got here two vectors, and here we know that vector AB plus vector BC here equals the vector A to C. It's almost like thinking you're going to Granny's. You're here, you're going to Granny's, and she doesn't really mind whether you go here via the supermarket and to her, or direct to her. She only knows that you've arrived. Often when we talk about these vectors, we give them little letters. So I can say here that vector A plus B will equal this one, which will be, if I want to get here, I would go C to B, which is going to be minus B, and well, we can do it that one. We can go from there to there and there to there. So we'll just have it A to B is the same as this vector, which is here A plus B. We can work out all sorts of different things here to try and work out what particular vectors are. Now, when we look at a vector, I can take a simple vector, and let's have a look at some of these. So let's have this vector. This is a 2 vector. This is a 4 vector. And this is an 8 vector. If we call this vector here A, then what we can look at is this one is going to be twice as much, 2A. And this one is half as much. It's half an A. These vectors are basically the same, however we've got here a different length, so we're multiplying this by basically a scalar, or we'll just call it a number. So we can use this to try and work out what all our different vectors are, and we can get little problems that will do this for us. So we can take a particular shape, hopefully thereabouts right. There we are. We'll just improve that one a little bit. So these two are parallel lines, so if this is vector A, then this one also has to be vector A. These are parallel lines. If this is vector B, then this also has to be vector B. And if we mark these in as A, B, C and D, if I want to try and work out this line going from B to D, so I want to work out vector B to D, well, I don't know that one, but I know it's this one. It is B to A plus A to D. And that I could write as here negative A plus B. And I wouldn't like that. That would be much better as written as vector of B minus A. So we can go through a whole variety of different little exercises here to have a look at and make sure that you're basically able to do some simple vectors, and these are very much what you'd meet in GCSE. So let's see if we can look at how else we can represent a vector. So a vector, I might say, could be a number. So A is at a position somewhere on this sheet, and let's say it's at 3, 1. So that just means that if I draw out some stuff here, it doesn't quite look straight. Ooh, that made it worse, didn't it? There we are. So it's a long 3, 1, 2, 3, up 1. That is where my position of A is. But I can now take this vector and I can decide that I may want to go somewhere with it. So we could say that that's a position, but we could have a vector doing this. And I can set up here some sort of vector, and this is going to be a vector, let's call it B, and this is going to be here -2, 3. Now, wouldn't normally write it like that. Let's write it as -2, 3. So we write it this way, and we see that this is now a column vector. And it means we're going to start perhaps here, apply this vector to it, which is going to go across in this direction 2 and up 3. So that would take my position of starting at this point and move it to that point. And if we know where we start, we can actually work out where we're going to end up. So a column vector is simply telling us by how much we're going to move something. So our first number, the -2, is going to be our change in the x, and our 3 here is going to be our change in y. And very simply, as you can see here, that if we're travelling in x, then positive is increasing it and negative is decreasing, and we can see obviously that y is going to be the same. We've got negative going down and we have positive going up. So we've got a way of trying to represent these vectors. If I take a vector, which is something like -2, 3, what I can do to this is I can multiply it by some sort of scalar. Let's give this a name, so that's going to be something like lambda. And if I want to multiply that, then I'd multiply the top by that and the bottom by that. So that's going to equal those two. If I want to add some vectors, and let's have these called perhaps A and B, and I want to add this vector to x and y, therefore these are going to be A plus x and B plus y. That gives us some ideas of these. So if I was given a vector, and I'll leave those up there, let's have a vector of 2 and 4, and let's give this vector a name. Unimaginatively, let's call it A, and I want to have half an A, then basically I will multiply each of those by a half, which will give me my new vector. If I've got a vector B, and we want here a vector of A plus B, then in the same way it's going to be 2 plus 3, and we're going to have 4 minus 1, which will give us 5 and 3. So representing vectors, not really that difficult. Now, sometimes when we write vectors, we can use unit vectors to try and describe them. So let's have a look at unit vectors. Simply what we've got here, a simple graph, and what we're going to do is we're going to call this one I and this one we're going to call J. And if I want to represent them here, I here could equal 1, 0. I'm going to put a line. The number of times I try and write these as fractions. And J is 0, 1. So J, if we assume this is position 1, then that's going to be 0, 1, and this one's going to be 1, 0. So we can write any two-dimensional vector in this form if we want to, because we know by the triangle law how things work. So let's draw out a little vector. So I've got here a little triangle, and we can represent this as A, B and C, and we can give these just things a number. So this is going to be about 4i, and this is going to be worth, not going to look very good, is it? This is going to look like, well, let's call it 2j. My diagrams don't sort of represent being drawn accurately. So this vector here is going to be 4i plus 2j. We know from this simple triangle law that vector AC will equal AB plus AC. Not writing well. So therefore we get our 4i plus 2j. And we could represent that simply as 4, 2. So any vector which is AB, then I could represent that by simply being AI plus BJ. So we can work out any particular vector. Let's have a simple example of this. Let's suppose I've got vector A, and this is going to equal 3i minus 4j. And let's have a different vector B, and this is going to be 5i plus 6j. And we're asked to find perhaps something really simple, which is can you find out what half an A is? Yeah, half an A is going to be 1.5i minus 2j. Can we work out what a vector of A plus B is going to be? Yeah, that's simply going to be this vector, 3i minus 4j, and we're going to add to that 5i plus 6j. Sometimes it's easier to just collect things like terms, so this is going to be 3i plus 5i, and to that we're going to add basically minus 4j and 6j. And I could, if I prefer, write those as 3 plus 5i plus minus 4 plus 6j. And that's going to give me 8i plus minus 4 plus 6 is going to give me 2j. So I can write them in various different ways. I could just as easily have ended this one up as that. So we can look at simple vectors, ways of trying to sort of work them out. Sometimes we're given sort of harder ones to try and solve, but they're not really that difficult. Let's just grab one. Let's say I've got A equals 5i plus 4j, and we can say that vector B is going to be 3i minus 2j. And could I find 2a minus b? Yeah. So how could we look at this? Well, I could look at A, if I wanted to, as simply being 5 over 4. And if I then want 2A, that's going to be 10 over 8. Yeah, and I went and put the line in straight away. So I've worked out what that vector is. I can work out what vector B is, and that's going to be 3 minus 2. So if I want to work out what this is going to be, then I could work it out simply as going to be 10, it's minus, so minus 3, and it could be 8 minus 2. And it might be okay to leave it like that, and it might not be. We might want to represent that as 7i plus 10j. we can put things back in whatever order we like. Depends on the question really, whether we think that that's appropriate or not. So let's have a look then at more about magnitude and direction. So for any particular vector that we're playing with, then we've got perhaps A here is going to be some number. Let's go for X times I, and Y times J, and that we would represent as X over Y. The magnitude of this is to work out, well, where we're actually going. So if we draw out here our little triangle, this is our I, this is our J. To work out this time our direction, we're going to need to do this squared, so it's going to be x squared plus y squared, because this is simply Pythagoras, and so my vector for my magnitude here, my magnitude is going to be the square root of x squared plus y squared. You need to be able to work out something about the unit vector as we try and go out, and the unit vector in the direction of A will be A over here, the unit vector. Let's see if we can put one of those into practice. We're going to see if we can find, question's going to ask us to find that simply given that 3i plus 4j. So we know that A is simply 3 over 4. You'll see why I chose these in a minute. It's going to be the square root of 3 squared plus 4 squared, and I can work that out hopefully in my head and say that this is going to be the square root of 25, which is going to give me 5. Now, could I work out the unit vector? Yeah, our unit vector is going to be A over this sort of direction, the magnitude here, direction, magnitude. So we've got here 3i plus 4j all divided by 5. Let's rewrite that. That is simply a fifth of 3i plus 4j, and that would simply be a fifth of that, which is going to be 3/5, which is 0.6i, or just 0.6 basically, isn't it? And over that, which is a fifth of that, which is going to be 4/5, which is going to be 0.8. And of course I don't want the line, do I? I've done vectors for years, and unfortunately in all that time I still keep putting the line in there without thinking. So we can work out a simple unit vector. So this is basically our magnitude and direction form. Maybe we're asked to talk about something. Can we perhaps find an angle? Maybe I want to find an angle here. Let's call it theta. You nearly see it. What do we know about this particular angle? Well, let's say this is going to be x-axis and this is going to be my vector, and let's have 4i plus 5j. So to work out this, let's think about what we've got. Reasonable. Here is my 4i. This is my 5j. So to work out the angle, this has got to be the tangent of this, which is the opposite over the adjacent, which is going to be this time 5 over 4. I can write that properly this time. And simply I need to go and work out what that is on the calculator, and I want to do the tan of 5 over 4 and it gives me, oops, silly schoolboy mistake, I didn't do the tan minus 1. There we are. Looks about right this time. So 51.43 degrees. So we can work out simply one of those by just putting the numbers in, so we can work out this magnitude and direction. What else can we do? Well, we can look at position vectors. Okay, so let's look at what is a position vector. These are vectors that give the position of a point relative to a fixed origin. Okay. So I can start off with here some sort of fixed origin, and we can give this vector a name. It starts here, it's typically called O, and we're going to call this vector, how boringly, A. Right, so let's see what we've got. We've got OA, my vector OA, and this is going to be something like AI plus BJ. We can work out then the position vector of this. A is going to be A, B. So in general here, if I want a particular point, then we can see that vector OA is going to give me AI plus BJ, and that's going to give me the position here of this. And we could sort of work out how these sort of things move around if we have a question with sort of various sort of other vectors in. So let's try a question, and let's have a vector that looks something like this. We can go up there, we can go here, and we can go there. Now let's see if we can make some numbers up. That's going to go along here. So this is going to be A, and we're going to go to B. I've got a vector this way, and we've got a vector that way. So here the points on AB have some coordinates, and we'll give these coordinates of 3 and 4, and this one is going to be somewhere like about 10 and probably up 1, I suppose. Right, let's see if we can work out what we've got. So can I find A first? Yeah, that's really quite easy. So I know that this is O, so we can say that OA, what's this going to be? Well, OA is going to be 3i plus 4j. Can we find the position of B? Yeah, this is going to be OB, and OB is going to be 10i plus just j. If I want to work out what the vector A to B is, well, how am I going to get from A to B? I'm going to have to go A to O, and then I'm going to have to go from O to B. Well, we know what these are. So these are going to be negative. So rather than write them as negative, I'm just going to write these as positive. So I'm going to do OB first, which is going to be 10i plus j, and what I want to do then is take away 3i plus 4j. So what have we got here? Well, I've got 10i minus 3i, which is going to give me 7i, and I've got j minus 4j, which is going to give me minus here 3j. In column vector form, this is going to be 7 minus 3. Can we solve lots of geometric problems with this? Yeah. And if we've got a problem, then we get these lots in vectors. You've probably met these sort of things in GCSE. I've got my little triangle, we'll call it O, A and B, but typically somebody wants something like this one, and we're told that point P here divides this segment in the ratio of, let's say, 1 to 2. So if that is the case, then I want to work out what OP is going to be. So let's give these vectors some names, because it's probably going to be easier. This is going to be the vector A, and this is going to be the vector B. So how do I get from OP? Well, to get to O to P, I've got to know something about AB, and we know that OP here is going to be something about some other things we know. So we know that AP to PB is going to be in the ratio here of 1 to 2. So I know that AP is going to be 1/3 of the vector AB, and I know that PB is going to be 2/3 of vector AB. Can we work out what AB is going to be? Yeah, quite easily. I can work out what AB is. AB is simply going to be AO, which in this case is minus A, and OB, which is B. And that's going to be therefore B minus A. So if I want A to P, we know that is going to be 1/3 of this, so it's going to be simply 1/3 of B minus A. And so to work out how to get from O to P, I'd need to go from O to A, and then I'd need to go from A to P. O to A is A, plus A to P is going to be 1/3 of B minus A. Now I don't like writing them like that. I prefer writing these as A plus a third of B minus a third of A. I find this way simpler to control.
Take a call from tablets.
So if I know it's a simpler way to control it, I can simply say I've got an A, I take away a third of an A, and that's going to give me 2/3 of an A plus a third of a B. And I find that way easier, but you may not. So it gives us a variety of ways of trying to play around with those things. So solving geometrical problems, not really that difficult, trying to work out some of these things with vectors. So finally we can actually do some modelling with vectors, and in mechanics we're often given a particular problem with vectors, and let's have a look at one of these. Typical problem is, let's suppose somebody here, and what they're going to do is they're going to walk due east, and let's suppose they're going to walk due east. Let's make it nice and easy. We're going to walk 3 here, and then they're going to walk due south of 4. So this is going to be my origin, this is going to be position A, this is going to be position B, and we've got my vector. Now, can we work out the total distance that's been travelled? Well, yeah, she's going to walk that distance plus that distance, so she's going to walk here. Ooh, not enough room. Total distance is going to be, she's going to travel 3 plus 4, which gives us 7. There we are. That was easy enough. Now let's see if we can work out the position vector of B. But relative to O. So I want to work out what this is. Well, this is going to be the square root of 3 squared plus 4 squared, and I chose my numbers wisely, so that gives me 5. Can we work out perhaps the bearing? We're looking at the bearing of B from O. So easy enough to work out this one. This is going to be tan, let me put in the -1 that I remember what we're doing, and this is going to be my opposite over my adjacent. This time I can write it like that, and all I need to do is go into my calculator and do my tan of 4/3. And that gives me 53.1. Now, what I've got to do now is work out what its proper bearing is. So I now know that that is 53.1. Of course, we had an additional 90 up there, so this is going to be 90 plus 53.1, and all we need to do is work that out as 143.1, and I've managed to work out a typical sort of problem of modelling with some vectors. Well, that was quite simple. I hope I've only gone through some simple bits and pieces. I'm going to save going through lots of questions and exploring those till later, but I hope that's given you an idea about vectors that you can go through, and you can use this perhaps to help you revise or perhaps even learn it in the first place. If you like what we did, then give us a thumbs up and please subscribe, and I will see you next week when we'll have a look at some more A-level maths topic by topic. Until then, bye bye.